Welcome back to my YouTube channel Being Engineer. This is the part 5 of the chapter Moment of Inertia. In this video, I am going to tell that the moment of inertia values for some of the geometrical figures which are predefined, and you will have to remember these values to solve the examples or numerical problems. In these figures are circle, it could be rectangle, isosceles triangle, right angle triangle, semicircle and a quarter circle. So let's start our today's topic, that the moment of inertia of various figures about centroidal axis, that is represented by Ig, that I have discussed in my previous videos, that is part 1, part 2, part 3 and part 4. If you haven't watched those videos, you are requested to please watch those videos to get the better understanding of the topic. First of all, we have a rectangle and centroidal axes have been drawn. Centroidal axes are those which passes through the center or centroid of the figure. Horizontal axis is x-axis and vertical axis is y-axis. This is the bottom or breadth of the rectangle, and height h is represented by h. And this is the y dash, and this is the centroid of the figure, that is the center or center of gravity of the rectangle. So its value, that is moment of inertia about centroidal axis, will be given as Igx, that is moment of inertia about x-axis, Igy is the moment of inertia about y-axis, and its area is given by area of rectangle is equal to b multiplied by h, and Igx is equal to bh cube divided by 12, that is moment of inertia about x-axis. If we take moment of inertia about y-axis, it will become hb cube divided by 12. Don't get confused with this formula. There is a minor difference, that bh cube and hb cube for y-axis. Now the next figure is right angle triangle. Similarly, the centroidal axis has been drawn, and x dash and y dash are the centroidal distances that I have discussed in my previous chapter. B is the bottom or base of the triangle, and h is the height of that triangle. So the area of triangle will be equal to bh divided by 2, or you can say 1/2 base into height is the area of the triangle. Similarly, moment of inertia for right angle triangle about x-axis will be equal to bh cube divided by 36, that is bh cube divided by 36, and moment of inertia about y-axis will be equal to hb cube divided by 36. So there is also a minor difference of b and h. In x-axis we taken the cube over h, whereas in y-axis we taken the cube over b. So don't get confused. Third one is isosceles triangle. Similarly, we have drawn the centroidal axis, the axis that passes through the centroid of the figure, and x dash and y dash are the distances along x-axis and y-axis up to the centroid of the figure. H is the height of the triangle, and b is the bottom or base of the triangle, and its area is also equal to bh divided by 2, that is 1/2 times base into height, and its moment of inertia about x-axis is given as bh cube divided by 36, similar as that of right angle triangle. But moment of inertia about y-axis for isosceles triangle is given as hb cube divided by 48. hb cube divided by 48. Remember these values. These values will help you out in solving the problems. The next one is circle. The centroidal axis has been drawn. X-axis and y-axis, and r is the radius of the circle. C is the centroid or center of gravity of a circle, as the area of circle is equal to pi r square, or it can also be written as pi d square divided by 4. This is the area of the circle, and its moment of inertia about x-axis is given as pi r power 4 divided by 4. Or you can write it in terms of diameter. It will become pi d power 4 divided by 64. Okay, now moment of inertia about y-axis is given as pi r square divided by 4. Now we see that circle is symmetrical about both axes, so the values of both moment of inertia about x-axis and y-axis are similar, that is pi r4 divided by 4 and pi r4 power 4 divided by 4. In terms of diameter, it can also be written as pi d power 4 divided by 64. The next one is semicircle, that is half circle, and centroidal axis has been shown over here, and the area of semicircle is given by pi r square divided by 2. Now if we take the full circle, its area is pi r square. Dividing it by 2, it will give the area of a semicircle, that is pi r square divided by 2, and in terms of diameter it will become pi d square divided by 8, and its moment of inertia about x-axis is given as 0.11 r power 4, and moment about y-axis is given as pi r power 4 divided by 8, and in terms of d it will become pi d power 4 divided by 128. Remember these values. The fourth one or the last one is quarter circle, that is 1/4 of a circle, and its area centroidal axis has been shown as in the previous slide. So the area of a quarter circle is given as, that is if we divide the circle into 4 parts, that is area of circle is pi r square divided by 4, that is quarter circle, fourth part of a circle, divided it by 4, and in terms of d it will become pi d square divided by 16, and its moment of inertia about x-axis is given as 0.55 r power 4, and moment about y-axis is given as 0.55 r power. That's all for today. In the end, you are again requested, if you haven't watched the previous parts, that is part 1, part 2, part 3 and part 4, the link will be given in the description. Please watch that videos too. These are quite helpful to understand the topic moment of inertia.